Hey, Arild Tørresdal. I'm working for a consultant company called Miles in Bergen. But before that, I used to work for an insurance company in Bergen called Forsikring. And my story is basically from those 6 years where I worked there, where we transformed that company into a different way of working inside of IT, so to speak. But first of all, why this DevOps thing? This is a quote that says, "The gap between Dev and Ops will in most organizations result in a major bottleneck, bringing with it significant hidden cost way outside of IT." Do you agree with that? Do you know who said that? No? I did, just now. So I couldn't find a quote saying exactly what I was experiencing or actually thinking about and expressing. So I just created a quote. Feel free to use it whenever you want. So what are these costs? Well, release planning and management, handoffs, queuing time, right? Handing stuff off to other people, manual labor and coordination to get applications into production, frustrating long delivery times, and both for features, bug fixes, so forth, right? Added risk of releasing too many changes at once. That's probably the most important one of these. But very often, it falls back to this, for me at least. If it's painful, do it more often. Just increase the frequencies, make the painful things really, really painful, really, really often, so you're forced to solve it, automate it, fix it, right? Like your SSL certificates that expires every second year. You started with 2 certificates, now you have 200, while they more or less expire every week, right? Well, let this SSL certificates have an expiration date of 1 week. That fixes your problem. So what are some of the gains around DevOps? And before I go into this, I just want to explain a little bit about my background. So first of all, originally I was a developer, but I was a developer very interesting in the operations side. So that's always triggered me. I always work with server stuff and networking and that kind of things. Which kind of, when I was working for organizations, typically smaller organizations, I had my hands everywhere, within networking, within programming, everywhere, right? And that was what gave me the kick, so to speak. So when I came into Frende, I saw all these inefficiencies in the way things were being done, and I started to look at some things and work with that. So what I'm trying to say is that it's really helpful for devs to know ops, right? So if you don't think that's interesting, there's a huge future for you if you take interest in ops. And the other way around as well, if you're an ops guy, there's a huge future for you if you start to take more interest in development. All right, gains of DevOps. Freeing time for highly educated and paid employees to focus on continuous improvement, right? So we're smart people, right? We don't want to do repetitive work. That's the idea behind it. And of course, that common competence between Dev and Ops usually result in better efficiency and innovation. Faster time to market, you always need to have that on your slides. And fast feedback loops from users allowing quick adjustments. And that is one of the things that I like, is think about things in iterations in feedback loops. And if you create something and then is about to put it out there somewhere where you want to have feedback as soon as possible if it's the right thing or not. So back to the company I used to work for. This is about, I quit the company for about almost 2 years ago. And I worked there for 6 years. So this is basically the story from that company for those 6 years. So have that back in your mind, is that these things also took more or less 6 years, right, to get to that point in time. So we kind of have these, what we call the reforms, or the lack of a better word. So if we look at the ops side of things, how was it before? Well, it was an external IT organization. Ops was bought, so to speak, hired. There was no access to servers in production. That's pretty common in many places. There was no load balancing during deployment. You'll see why I bring that up as a particular point. Everything was virtualized except from database servers. Changes and deployments was executed by the hosting provider, so you get a handoff to stuff to the hosting provider or the operations side. There was basically no monitoring. We were really lucky if we were alerted about a disk being full or something like that. Usually we figure it out by reading the error messages in the different applications we were creating. Now, actually now is like 1.5 years ago, there's a new IT operations company, but still external. There's a clear separation between dev and ops responsibilities. And this is, so when I work with customers today, there's always this hard thing where you need to figure out what's dev's responsibility and what's ops responsibility when devs are taking more responsibility inside of ops. And for me and for the companies I work for, that's usually that the operations side take responsibility for the infrastructure networking and those kind of things, the servers, the virtualisms around the servers and all that. And the devs takes responsibility for their applications, what they've created, what they know how to host most efficiently. I'm not saying that's the answer all over. I'm saying we've had really good experience with that separation. Dev has full access to all environments, including production. There are no changes allowed on any servers, meaning changes are as infrastructure as code, meaning you're using Chef, Puppet, Condep, some kind of tool to do that, scripts, whatever. Just don't go into servers and make changes directly. Everything is virtualized now, including databases. There's a sticky load balancing to ensure optimum scaling of the deployment. And remember, we're not talking about sticky load balancing as in scaling the application. You want probably to have your applications work in a round-robin type of scenario, but sticky in a deployment sense is to optimize so that when you deploy, you only take one server out of the cluster at a time and stuff like that. So you don't want to bring half your stack down just to do a deployment. Monitoring in production by dev. So the responsibility for monitoring the applications in production is a dev responsibility. And when you do that, interesting things start to happen. Like monitoring tools start popping up. Stuff we never had before, because suddenly devs have this need of seeing stuff that they didn't see before, and they never figured that they might give these tools to the ops guys. But now when they're in this, have this need, they create it. And a hosting provider or the operations side more or less just provides the bare OS. Bootstrapping and configuration of servers and deployment is fully automated. So that's on the ops side. On the development side, so this is a Windows.NET shop, right? And if you think that doing these things in Linux is hard or Unix is hard, try doing it in Windows, right? That's a completely different problem. But Team Foundation Server, which is a Microsoft product, was used for source control and build stuff. There was some unit testing, but not structured. There were typically code freezes before each release, and database schema changes was generating by diffing test to production. sound like a great idea at the time, right? A lot of bug tracking. Today, however, well, there's some other products used for build, not really important. Git for source control, so they moved on to something better. But unit tests and integrations tests are used when needed. And this organization came from like doing next to no automated testing to do extremely automated testing. Everything had a test harness in some way. And the pendulum went like this, and then it normalized somewhere in the middle, and they learned to make decisions for when they want to do certain type of tests or automated tests for the systems. What they discovered is that a high degree of automated tests also has a great cost, so you need to balance this. There's never any code freeze or anything like that. There's extreme focus on low complexity and microservices and that kind of thing. But that was kind of an architecture that evolved with this whole process at the same time. Yeah, every push to Git basically could end up in production at any time. And that does something with a developer's mind. And you might think that, oh, those devs doesn't push very often to Git, do they? Actually, the complete opposite. They push like 1 and 2 lines of code into production to make sure that they're in full control of this tiny bit that's going to production. And the nice thing about that is if something goes wrong in production, the error is like in one of these 3 lines of code or whatever. It's really easy to find, it's really easy to fix, and it's really easy to move forward. And then something probably some of you want to talk to me about later, no branching at all. And I'm talking long-lived branches, right? Long-lived meaning a day or more, right? Because when you start to do these iterations this fast, branches get in your way. Actually, they're always in your way. You just don't notice because you're not moving fast enough, right? And there's little or no bug tracking, which is also an interesting topic, is that how can't you do bug tracking? Well, it's really simple, actually. Just solve your bugs when you find them straight away. Because it's a bug on a feature that has had a higher priority to begin with than whatever you're working on now, right? So either you say, this is a bug, I'm going to fix it, or you say, no, it's not a bug, and you like throw it away. All right, as for deployment, typically you create these packages that were handed off to the operations side, and they did this about once a month or something like that. And typically they did rollbacks once a month because there were errors, and they spent some time to actually getting this release out every month, right? Typically early morning, late night in order to get this out, so you don't get in the way of the customers. We were lucky that there wasn't any 24/7 type of requirement here, or actually there was, but no one noticed at the time. All deployments are now today automated. That's the easy part. That's the processing around this. That's the hard part. You can deploy it any time without any downtime, right? Actually, they prefer to deploy new stuff into production in prime time. When there's the highest peak of the system, that's the time you want to do your deployments, because that's when you find out if something goes wrong. And this might sound hazardous or something, but actually there are some things that you just can't figure out or test, no matter how much you test, and you won't see the real effect until you get it out there. And if you can really fix any errors really fast and redeploy, this is a good way of going about it. And it might sound like, oh, you like introduced tons of errors all the time, right? No, we didn't, because there were all kind of other things that prevented us from doing that. But yeah, multiple deployments to production every day. the concept of a deployment pipeline, and we'll talk a little bit about that soon, but that more or less ensures that everything goes through a process and are quality tested. A lot of use of canary releasing, meaning you can like give certain set of customers access to certain functionality before others, or get your internal company people access to some stuff before the customers and stuff like that. When it comes to like technical stuff like schema changes to databases, I don't know how many years and of waste we've spent on trying to solve that, but in my opinion, there's only one solution. You need to be backward compatible and forward compatible. That's it. It's as easy and as difficult as that. So no rollbacks, forward only. Fix the error and then redeploy. So basically this company has continuous deployment in test and pre-production environments, and they have continuous delivery in production, meaning everything is automated in dev and test and pre-prod, but somebody clicks a button in order to take it out to production. And of course, since it's all automated, there's also full audit of everything that happens, right? So we can track who did what and who triggered which release and what code was related to that release and so forth. So process-wise, this company was in rapid growth, right? It was not a startup. We're talking an insurance company here. I'm not sure we can categorize them into a startup, but they were in rapid growth. They had this Scrum-like process, really Scrum-like process. Business typically expected something to be released on a fixed date, right? There were long feedback loops, so what they kind of ordered and what they saw was like this huge step in time. Yeah. And typically they manually tested their entire application suite before every release, because they had to be sure that everything worked, right? That's of course because you change so much, you have to retest everything. So today it's a company with high cost focus. So in insurance, this is typically referred to as combined ratio. So that is something that they have really high focus on. There's a Kanban lean type of process, so we've kind of moved, we did Scrum for quite some time really well and moved on from that to something else. I'm not saying that's right for you, but that was what we found was effective for us. But the most important thing here is the lean part, because basically the lean concepts and ways of thinking and theory constraints and all that is integrated into all these ideas and ways of thinking that we've used here. Yeah. So, and stakeholders, upper management, participate in daily stand-ups. And it's this a story from one of the CEOs of the company who went past a group who were having a stand-up, and there's this Kanban board on the wall with some notes here, there, and it's like this line of notes on some column, right? And he has this lean background, so he walks by this office and stops back and like, what's that? Oh, that's waiting for test. Okay, so why it's not being tested, right? You have a huge bottleneck here, and in order to solve whatever you're doing here, you just need to fix that. And it's going to move a lot faster. And when the CEO says that, things became a lot easier. But of course, we also started talking about these lean concepts, and things are starting to, people are started to understand these things in different ways, or better ways, and it all become a lot easier. So, but even more importantly, they're now aware, the whole company is aware of the increased risk with infrequent releases. People are getting, like on the business side, getting really uneasy if there's like more than a week since we've released this application or something, right? They are aware of the risk of putting too much into production at the same time. And they actively use canary releasing, which I mentioned earlier. And they're continuously involved in the process to give you feedback and ensure these feedback loops are flowing, so you can get whatever you want to get out into the customer hands. Right? So as part of this process, and I'm going to take this really quick, and we can talk about this later for those who are interested, but we more or less established 9 technical, if you want, or semi-technical principles around doing DevOps in this company. The first one was the deployment pipeline. So who has not heard about what a deployment pipeline is? Right, next one. So this is just an example from Team City where we've created a deployment pipeline. But that basically ensures that whatever you create gets quality checked across a pipeline, and hopefully it's a good thing that comes out in the other end. But then we have this concept about deploy versus release. And I think that many talk about those things as the same thing. However, you can deploy to production without releasing functionality to users. So basically, continuous deployment, you can do that without releasing anything, right? And that's a powerful concept, because you can basically continuously integrate things into production without touching the functionality of the users. And of course, the technique you use to that is typically feature toggles. So, and that's also the replacements of doing branches is doing feature toggling, right? So we've talked for many years about the bad things about branching, but no one really came up with a good replacement for it. Well, I'm not saying this is a replacement, but this is a tool in your toolbox that you can use, and sometimes it's instead of branches. So, and brings me to the fourth point, which is no branching. And just to say a few things about that. So when you branch, you basically opt out of continuous integration, right? Because what do, right? You don't integrate stuff anymore, right? You separate things into different lines, different branches, and you move like this. You don't integrate, you move like this, right? So at the time when you actually do a merge, that's when you integrate. And people say, well, I have my own CI stuff running for this branch. I have my own environment for this branch. Yeah, well, you're still not integrating, right? You have this environment over here, which is separate from anything else. You need to continuously integrate, right? Think about continuous integration as this thing, not as a server, right? Because developers typically think about CI as a server. So, of course, the obvious thing, no branch, no merge. But the alternative to branching is, as I said, feature toggles. But if you still insist on branching, note the following. You get reduced delivery capacity, you get reduced quality, increased risk of errors, and added complexity. And of course, that's just something I say, right? So don't take my word for it. But that's our experience, right? But you don't see this until you start to increase the frequency of your feedback loops and the way you release and these things. Then these things are really starting to hurting you, and branches become one of those painful things. So the other one is no manual changes on servers, which I've talked briefly about. And there was something from Microsoft that said something about that, ironically. Whenever there's a new project or a new thing or an application or whatever you do, this company deploys Hello World to production. That's the first thing they do. They make sure that their deployment pipeline is fully functional, and then they start their development, right? And they continuously deliver things into production, but they don't release it, right? Because the users don't have access to it. Well, maybe they give access to some users, but they continuously put it out there from day one, right? Yeah, version control of infrastructure, the seventh point, that's what you get when you do infrastructure in code, basically. That's kind of an added benefit, as long as you remember to check it into your source control system, which would be stupid not to do. Canary releasing, we already talked about that. Netflix was one of the first to coin that. And And then we have this discussion around done, right? How many of you guys have been sitting in meetings for, I mean, I don't know how many days of your life discussing the definition of done, right? So the thing is, done is in production. It's not done or done or whatever you come up with, right? Done is in production. And there's always this wise guy who says, well, is done in production or is it deployed? Well, I leave that up to you if it's deployed or released, right? That's that kind of definition. But the point is that when you have this process where you quickly can get things out there, the definition of done gets really a lot easier to handle. So basically a summary of the 9 principles. There are some improvement points with this organization, of course. Since they're on a Windows platform, the container adoption kind of takes its time. There's smoke testing, performance testing, and so forth. But if you want to know a lot more about this, and basically what we used as the Bible, in a lack of a better word, was this book. So I expect a lot of you have already read it, but if you haven't, you should really do it. So that was a 1-hour presentation in 30 minutes. Thank you.